Hello guys, welcome back to session 2. Alright everyone, if you have your friends who haven't joined the session yet, you can just call them up and ask them to join because we'll be beginning in the next few minutes. Okay guys, so let's begin with today's session. For session 2, we now have Mani Krishna over here who's going to lead today's session. He's from ECA guys. So Mani Krishna, you can take over now.
Yeah, thanks, Amit. Yeah, hello, everyone. So, let me just introduce myself and we'll go into the session. So, I'm Manikrishna Kari. I'm currently studying in my final year of my BTech in Information Technology. So, currently, I'm a member of ECA. So, I just want to not teach you something big because this particular session it's about beyond coding. It's not related to technical thing. It's not completely related to technical thing, but I just say how applications are built in real life, in the software development industries and all. So we'll just learn introduction of every application tool we use in the software industry and all. So I'll just give a glimpse of what are the application, one of the tool, and also how applications are built in real time, so that you'll have an idea of, it's a very advanced topic. I'll just give an introduction of that. I'm not going to teach completely, so you can explore it further in your own resources or something, or I can share any resources if I find any. Yeah. So let me just present my screen. Is my screen visible, guys? Can I get a reaction or something? I hope it's visible. Yeah, good. Yeah, we're good to go. So let's say, we are talking about the industries thing, right? So how industries work, how a developer works in a software industry. So we'll just have a look into it. So I'll just present it completely. I hope my screen is visible. Okay. Okay. Have you ever heard about Docker? So let's learn about Docker. So this particular logo is the Docker logo. Why do we require it, and what is the use case of it? So let's start the session without any further delay. I just wanted to ask a simple question. Imagine we are building a project. Let's say it's a simple React project, hello world kind of thing. So it works perfectly on our system. Since we are building it on our own systems, even if we wipe code, something we'll just have all the dependencies. We'll just install our node modules and all. So we'll make it run on our system. So imagine you're pushing it into the GitHub, and one of your friend asked you to show your project, and also you wanted to collaborate in it. So you just share the GitHub link and ask him to clone. So he's just trying to run that project in his system. So you have an Windows laptop, you have an MacBook, or let's say this possibility you're running the project in Node 22 version, is running into Node 18 version maybe. So what will happen? So you just launch the project. So your friend downloads the project, and do you think it will always work on your friend's laptop? Maybe sometimes it will work. No, most of the cases, even most of us would say yes because it works on our system. But surprisingly, many times the answer is no. Uh, Let me explain this. So I have just built a project, a simple React application. Let's say hello world application, and the dependencies are I have used Node version 22, Node.js version 22, and I have installed in my local system, and everything is good in my system. So as I said, my friend cloned it from the GitHub. So he already have a Node version of 18, Node.js version of 18. So there will be some missing packages in his system. So he tried to run my code, npm run install kind of thing. He does that stuff. Still, he gets an error. The code doesn't run completely. So why is that? Because we are not sure about what are the versions we use, what are the packages we install, what is the operating system we use and all. Because one of my friend uses Mac, one of my friend uses Windows and all. So let's talk about the environment. What is environment? Let's say environment means everything required to run your application. Everything required to run your application. Let's say, for example, for my project, what is the environment? Node.js, npm libraries, all the dependencies and all. So if any one of these is different, then we say environment is different. Let's say my environment is different from the person who uses MacBook. So their environment is different. So this is the traditional problem we are facing while we share the project code thing. So normally, if I send my project to my friend and tell him to install that, he'll face this system. He'll face this issue. That environmental difference and all. So now let me introduce to Docker. So what if I can send him the ready-made environment? The environment which I used to create my project. I'll just share him the environment to his project. He need not install any type of environment or packages in his own system. I'll just send him. I'll just pack the application. I'll just pack everything. The dependencies and all. I'll just pack him. Let's say I'll pack him in a lunchbox and I'll send that lunchbox to my friend. So does this work? Yeah, it works. So that's where Docker comes from. So in simple terms, what is Docker? A Docker is a tool that lets us package our application along with the everything, dependencies and all. We'll just package that thing application, and it needs to run from that package. So when we are talking about the Docker, we'll be having few keywords. Let's say when we are talking about Java, we'll be talking about the class objects and all, right? So similarly, when we talk about Docker, we'll be talking about few keywords. And also, again, I'm not going that deep into Docker thing. I'll just leave it to you. You can explore the Docker thing because this is not completely technical session. So the title itself tells beyond coding. I'll just introduce the applications and all, and I'll just give a glimpse of system design and also after this Docker thing. So I'll just make sure that you know why this is used. So uh, let me dive into the Docker. So in the Docker, the first keyword, we listen it multiple times. It's a container. So what is a container? Let's say, as I said before, think of a container like a lunchbox. We are telling that let's pack the complete application and all the dependencies. So where do we pack it? So inside a lunchbox, what we generally pack, we'll just pack food, spoon, water bottle, and something, napkin, tissues, etc. So everything needed is already inside my lunchbox. In the same way, so inside my Docker container, I will be having my application. I mean, the dependencies, let's say Node.js, libraries, dependencies, configurations, and all. So everything needed is already inside my container. So that is called a container in the Docker terms. So same with the Docker, we'll call it as a container. Okay, container fine. So while you are building project, we should be aware of the Docker file. So what is the Docker file? Let me share my. Let me show me a simple project. So I just created my simple React applications, all over application. So welcome to your React tab. I just implemented a counter button here. So this is a project uh, that only runs on my system because uh, I just did it now. So let me show the use case of Docker in a simple, practical manner. So will not go deep into the Docker, but I'll just show why we use it. So this is my output of my screen. So let me share my code too. Yeah. Can you see my VS Code? Yeah, fine. Mm, yes. Yeah, we're good to go. So initially, my project doesn't contain any Docker file, so I just created a simple React project. Let's talk about the Docker file later. So what I'll do for creating a React project. So if anyone knows React, you know. So for the people who don't know, we'll just create a React app using Byte something. We'll just install the dependencies, and we'll just write some simple code. I just wrote some welcome to React app something. So and also I created a card button, and that's it. This is my project. So forget about the Docker file. So I just wanted to share it to my friend, and he told me that he doesn't have any Node.js and all. And I asked him to install Docker in his system. Let me set up the Docker using some AR. He just saw a tutorial of installing Docker. So that's fine. So I just added a Docker file. I just added a Docker file into my project, in this project. So why is this Docker file needed? This particular Docker file tells about my project. So when it is run in the Docker, it just tells me what is the dependency I used. How do you run that project in your system and all. So let us know something. Let us know briefly about this. So this is my Docker file. You can see there from. So I just started with my Node.js version 22 from Node.js 22. So you are getting a project from the Node.js 22 version. And also I have created a folder called app inside. So and working directory will be app. So create a folder called app inside Docker. It just tells that to the Docker. And also copy my package file. So simply we'll be having a package.json. So for every project, this particular package.json JSON will be containing all the dependencies, because all the dependencies like what is the type of this project and where to start, how to start and all. So this particular package will this is a default package containing all the dependencies in your local system. In the same way, Docker file is also similar to package.json, but Docker file is related to the Docker application. To run into the Docker application, we'll just write Docker application. So copy all the files dependencies from my package.json. So that's what it's telling. And then we can see the run npm install. So this npm install is not happening. Let's pause here. Let's say run npm install will when we work on our local system. So when we click npm run install, so it will be installing in our system, local system, but we don't want that. So I asked my friend to install Docker, and so he is doing in the Docker. Now and he can also integrate Docker into his VS Code terminal. But there's another way also. He can directly log into Docker. I mean, open the application, and he can open the CLI there, and also he can run the application there. So this particular npm install is not happening on my laptop, and my laptop in the sense my friend laptop. So Docker is installing everything inside its own environment. So let's say Docker environment, it's installing all the dependencies and all. Am I going too fast? Uh, okay, I'll just tell it slowly because it's all theory part. I'm not going dive into the coding and all. So let's get into track. So this is very important for us. This particular npm install is installing all the dependencies in its own Docker environment. And after installing all the environment, so copy the remaining project. Let's say copy and all, and expose 5173 is my port. So my application runs on that port. And also when now the container starts, it's automatically run my React application. So let's see. Let's open Docker. How do we do that? So that's all about the Docker file. So we'll just add this simple Docker file into my project and tell the Docker that these are the dependencies. This is where my project is coming from the Node.js 22 version. So you copy all the packages and all and expose it to the 5173 port. That's URL my application should run. So we are all telling the details to that. So let's see how Docker does that. I'll just share my Docker. Just a minute. Okay. So this is my Docker application. I have opened my Docker application docker.exe file. So what I does was so, so this is the simple interface we'll be getting. So here is the command prompt kind of thing. It's within the Docker desktop. It's a terminal directly within the Docker desktop. So I'll just click into it. I'll just delete all this. Okay. So I just I just got into my directory where my React app is built. So I just got into my directory. Okay. From here, I'm just running a simple command. Let me explain that command. So Docker build command. Let's build our Docker environment. So, and also, you may ask that out. This application is sent by your friend. How do you get it in your system? So we'll just clone from the GitHub, and we'll locally install all the files. But we'll just not install the dependencies. We'll install all the source code and all, but we'll only skip the dependencies part because installing Node.js for different versions of different projects, it's a hectic work for us. So we'll just install Docker and we'll install all the dependencies for that project in this Docker environment. So I'll just type a Docker build command. So I'll just build Docker build and I'll just give a name, React application, uh, React demo. Uh, Before running that, let me explain every word. This simple Docker term. So it tells that use Docker. So I'm telling Docker to use Docker. Don't install anything in my system. You need to install it in Docker environment. So for that, I'm just using the keyword called Docker. And then after build. So what do you mean by build? Create something. So we are just building an environment here. We are just building a project here. So create something. So the build actual meaning is build. To create something. And then this -t is like give it a name to your environment. So I'm just giving it as React demo. So I'll just run it here. Okay. And also built in this current folder. So I forgot to mention that dot period there. So my yeah. So my Docker started building, started extracting the packages from my project, and it's already installing all the dependencies and all into my Docker. So I just run a the command here docker build.react demo. So it installed all my dependencies, all my packages here. So let me see how can we run that. So I think you're clear with the Docker command, for building the container and environment. So then we know what is a container. Now let's go what is an image, another keyword image. So image is like a blueprint of that. Let's say it in Java terms. Have you ever heard about class and object? So object is like a blueprint of the class. It's an instance of a class. In the same way, image is the blueprint. It's an instance of a container. So container is the running applications and image is the blueprint. So to run this application, we'll just type here Docker images. So it lists out all the images, all the containers we are using and all. So now we'll directly report to the container. I just copy pasted this because I have not done all of my notepad. So what does this command tells? In similar way, so now use Docker and run this particular application to my port number 5173. So now Docker creates a container from our image, from the blueprint of that image. It's creating a container. So we can open browser and log into that application. Let's just run it. Open my browser. So what does it telling? So your application is running in this particular URL. So let me share that screen too. Just go into this website. Yeah, you can see in my VS Code, I didn't started my server here. So this particular application is running from my Docker. So since we have built an environment, everything in the Docker, from that I'm redirecting to this URL. So definitely my application works here. So for this, you can think it like, it's a more, it's a more complex process than the cloning and we can install the dependencies. But for the simple project, it may be felt like, complex process. But what if you are having multiple dependencies? You need to install large number of packages, large number of libraries and all. So that time, this particular Docker helps you in a better way, in a easier manner. So that's where Docker, how Docker works. And also, if you see, I never typed npm install npm run dev into my systems because I don't need that. I don't need it to my systems. So my Docker does everything for me. So my Docker it installs all the dependencies. It does everything for me. It does everything for me, and it just gives me the direct URL. Where I can see my demo of my project or my friend project. So this is completely about the Docker. There will be other comments as well in the Docker. So you can explore them. You can explore them. So for the people who are in their second year or third year, explore more about the Docker because it may help you. It's like it adds some weightage to your resume as well because you can create multiple projects with a single application called Docker. You need not to install multiple dependencies, multiple libraries, and all. So Docker does everything for you. So that's all about the Docker. I guess everyone got an idea about Docker. So that's a one tool which I wanted to introduce you all. So and also let's come back to our session. Our session is titled as Beyond Coding. So what do you mean by beyond coding? So as I promised you, so I'll just telling you the how real software developers works in their system and all. So let us go into that also. So before that, I just want to introduce you all to the Docker. So I have done that. And if you have any doubts, you can text. But think of it as like a more introductory session for the Docker because don't dive deep into the Docker now. You can explore it later. So build a project and ask your friend, or ask your friend to share any project he built, and you can try that out into your Docker running. So this will be helpful for the open source. If you are a open source contributor, you can do that in the Docker, without installing all the dependencies and all. So that's it about the Docker. So let's see what is beyond coding. Why is this session titled Beyond Coding? Okay, let me introduce to a topic which is a very complex topic. This particular topic will be asked you in many interviews. No, not also in normal category interviews. You will be asked in dream category interviews. Let's say this particular topic which I'm introducing you now, that will be asked you in most of the fan companies, man companies, and all. So imagine. So let's forget about that. Let's take a simple use case. Imagine you are building an application. Let's say you are building an Amazon application or Instagram application. Let's say WhatsApp. You know, Google, something application you are building. So you got a job. You are into a software industry. So you are building an application. So let's say this particular application that you are building, it will contain some millions of lines of code. You all know. So don't you think Amazon contains millions of lines of code? Don't you think WhatsApp contains millions of lines of code? And also millions lines of code built by hundreds, sometimes even thousands of developers working on the same code base. So in this large scale of applications, we'll be having millions lines of code and built by thousands of developers. So let's say each developer built a solution in his own way. Let's say someone duplicates the code. Let's say five people working on the same code base. One particular guy builds some unnecessary objects. One particular guy duplicates the code. One particular guy, he creates a solution in his own approach, which is not scalable. Maybe one particular guy, one particular developer, he needs to build something which is very scalable. So he thinks in the same way, that way. So, different thoughts, different solutions given by different developers into the same code base. That's the problem. No, you can't build a project on your own, right? So even if you get into a job, even if you get into a developer role, you can't build something on your own. Let's say you got a client and he asks you to build an Amazon client, he asks you to build a website for Amazon assessment or Amazon career site. So you won't be building entire Amazon career site. Let's say how we build for our resume projects. We can't build like that. So you will be having a team. Let's say minimum of 20 people team. So you will be assigned a particular part of the website. You need to work on it. So that's how in software industry it happens. So what is the problem then? So let's say 20 people are working on the same code base, and we have just seen few problems. How different people create different solutions effectively. So what is the problem? The problem here are listed out here. It's very hard to understand who is doing what, and also it's difficult to maintain that uniformity and durability of that code. And also it's difficult to extend. Let's say we have finished this somehow, and also we need to add some more extra feature. We don't know who built what. Like he built some particular approach, he built in some particular approach, and we can't align both of them. So these are the problems arises if without any planning, if you does the project. And also it's bug prone. As I said, some people who is very bad, let's say who is very bad, he duplicated the entire code. He just wanted to know the error, so he just copy pasted. Instead of copy pasting, he just copied the entire code and he pasted in the same code base now. So he duplicated the code. Let's say that's 1,000 lines of code he duplicated again. These all things, and also it's expensive to develop too. So these all things arises while you are building in a team. While you are building in a real time also. So how do you solve this? So what is the meaning of software engineering? Come on, read this thing, software in code. So software engineering is not just about the writing code; it's about writing good, maintainable, reusable, and scalable code. So that is what software engineering requires. Even if you are a software engineer, you need not to just write the code, but you need to understand. You must understand all these rules. How to write the code, how to make it effective, how to make it efficient, reusable, scalable, and all. So you should focus on these things actually. Um, let's say one more story. So this particular story I have seen it somewhere in YouTube, and I brought it to you. So software design is more than algorithms. Let's say they have two friends. Let's say okay, I and Soumit are there here. So I only know DSA and Soumit knows DSA, OOPS, and LLD concept also. I'll just dive into LLD too. So don't panic. So let's say we have two friends, friend A and friend B. Friend A only knows DSA, and friend B knows DSA, OOPS, and LLD too. So let's say we got into some project and we are only members in our team who does the coding part. So our manager wanted to test our skills. So he assigned a project that we need to build a quick riding application. Let's say we need to build a Rapido kind of thing. We need to build a something Uber kind of thing. So we just assign that work to us, and somehow I got cheated in the interview and got into that company. But I only know DSA, or let's say I only know the full stack development. I don't need these all principles, SOAPs, concept, LLD, and all. So I only know DSA. So what is my thought process then? You just asked me to create an application, quick writing application, let's say Uber. So what will be my thought process with the skills I know? So what I does, I'll just think everything in DSA manner. So what I'll do was I'll just treat everything, though this connection points, roads as edges and all. No, I'll just treat roads as edges and all connecting points as nodes. So I'll just create a city map. From that city map, what is the main use case of that quick routing application? We need to find the shortest route. So for that, I'll use just Dijkstra algorithm. So I'll just use Dijkstra algorithm because I know DSA well. So I'll just convert this entire city map, into my graph concepts. And I'll just use Dijkstra algorithm, and I'll use priority queue, for picking up my rider, or for the shortest path calculation and all. For the ride matching, I'll just use a queue or something. So I'll think it only in that way. So I'll just write the code for these all things and I'll present it to my manager. But my friend who knows DSA along with OOPS and LLD, what he does, is he'll just list out all the requirements first. What are the requirements you need? You'll just list out all the requirements. Let's say for building an applications, what are the use cases? What are the resources we need? We need users to use my applications. We need drivers. We need rights. And then after, we'll just focus on the futures. We need payment gateway. We just need notifications also. And from that, after for those managers, resources, let's say we just need to build the relationship between users and driver. We just need to build a relationship between the rights and users. We just need to make sure the security, exposing all your personal data. Let's say you have booked a ride, and that particular Uber driver can call you through your number, and after the ride ends, will you be happy if he still uses your number to call you and all? So it's not correct, right? So you know that you should maintain the data security too, without exposing and all. And you should also think of it the scalability. Let's say after rolling out your application, it will be used by thousands and let's say not thousands, it's millions of people use that application. So will that application run smoothly? So that's where scalability comes. So he just first thinks about it. This is all the things, these relationship managers and all. The first focus on all these things, and then he jumps into the algorithms. So, what I does it first, that's a team up thing, the X algorithm. He does it at the last step. He does it last step. But before that, he had made sure that how the relationship between users and drivers should be, users and drivers right should be. So he had made sure that all these things are done, and then he jumped the algorithms and coding part. So he presented his project to my manager. Guess how does my manager feel? Will he promote me or my friend? So what do you think? Will he promote me? I don't think I will get a promotion because I just got I just cheated into my interview and I just come into this job. But my friend who knows his all things, even though he's average at DSA, he'll just gets a code from somewhere here and he does the complete project. So definitely my manager will be happy with my friend because what managers, what clients see in software development is that scalability thing. That scalability thing. Your application will be used by millions of users. So uh, let's also say a simple example. So we are booking a movie ticket. Let's say we are booking a movie ticket for some movie, and I just booked seat number 10 into my phone in my phone. So somewhere in other place, some one person who is a stranger, he also uh, he also selected the same choice of my seat. So I click the seat. He is also clicking the seat. So what if we get the seat to the both persons? Will we cut that seat and use it to use it by both persons? That's not right, right? So that's where problems arises. When you jump to coding directly, these all problems will come. So for that, we need a software design. So that's the thing I wanted to introduce. So most of the, not most, so every software industry uses this software engineering term. So software design, so which we call it as system design. So have you ever heard of system design? So this is what system design, software design. So for the software design, so most of the people before writing code, developers think about the how many classes should exist. Let's say we are building something in Java. So what does developers think before writing the code? So if you are a developer, you must think these things also. How many classes should exist and which class should communicate with what class, and also how many objects should my class contain, and all these things. Software designs before writing the code, they will discuss these all things. So this particular planning phase is called the software design, or we can simply say system design, but no, that's not the exact definition of system design. We'll just dive deep into that also. So this particular friend B, so what he does is he just implemented the software design. So he followed the pattern, he followed a pattern, and he just implemented the software design. But I only did my coding part, but he does all the software design part. So l- for the software design, we'll be having two different types of designs. Let's say high level design and low level design. So what does high level design do? So it's all listed here, but I'll just give a brief about that. And again, I'm not going deep into these things, so I'm reminding you it again, so you can explore system design too. System design is a very advanced topics, and which is most required topic for this current market. Without system design, you can't get into that high paying jobs, 40 lakhs, let's say 20 lakhs, even that high paying jobs you can't go without system design. You must know these all things, and it's a very vast topic, so I'm not going that deep. As I said, I'll just give an introduction of all these things, system design and all. So let's go into this. So we have two types of designs, high level design and low level design. Let's just talk about high level design now. I can give you one design pattern too in low level design. I'll just introduce low level design deep, and then I'll leave high level design to you. You can explore that. So let's just know brief about the high level design. So high level design is also known as system design. So high level design is also known as system design. So what does it focus on? It focuses on architecture of my entire system. What do you mean by architecture? As I said before, this particular friend, what he does, he thinks of scalability, right? So that particular architecture of the system will be focused in high level design. So it answers questions like how do we scale the application to millions of users? What databases should we use? What is the tech stack we are gonna use in this project, this particular project? So and since we are building a huge project for the millions of users, so what is the tech stack we need to use? So what tech stack prevents user to jump from that errors we see? So how does it make scalable to all the users? What tech stack does it make? And how do systems communicate? How does it communicate in one system to another system? How does it done in Mac? How does it done in different operating systems? How do we handle traffic and reliability and all? So this all things system design answers. So high level design focus on architecture of entire system. Uh, so let's just go deep into high level design. You just say when an interview asks you about the high level design for any particular interview, you just say high level design focus on the architecture of the entire system, and it answers questions like what database should I use, what tech stack should I use, how do I scale that project and all. So it focuses completely on the system. So we call it as system design also. So that's where high level design, you can just say this brief about to the interviewer, and believe me, the interviewer impresses to your answer. You just say these definitions, definitely the interviewer will, he gets impressed, and he'll definitely move to, promote to the next round, or he may give you the job. So that's the importance of high level design we are having in the current market. Oh, so that's about the high level design. And let's move into the low level design. So what do you mean by low level design? So low level design. This particular low level design, so what does it focus on? As you can see, it focuses on internal implementation of the system. So I'll just talk in Java terms because I feel if you talk in the Java terms, it will be very easy to understand. So I feel that correct me if I'm wrong because my primary language was Java. So I'm just going into Java terms. Okay. So what does this low level design focuses on? It focuses on internal implementation of the system. So let's say how do objects interact with other methods and all? How do we avoid code duplication? Let's say one particular method is being used in multiple parts of the code. So how do we avoid that? We'll just write functions, right? So in big applications, how do we avoid that? How do we make code flexible? And also how do we reduce the code? Let's say for a project, do you really think we need millions lines of code? But I don't think we really need million lines of code, unnecessary code. We can optimize the code, we can make it readable, we can make it pleasant. So we can organize the classes and all, we can organize them into packages, we can organize them into modules and all. So we don't need to write entire big lines of code, which looks clumsy and which makes difficult for us to read and understand the code. We don't want that. So there will be some solid principles so to code, uh, like single responsibility and all. You can explore that also. You can just go to YouTube and type solid principles. You will just get the introduction of all the system design that we are talking. So I just wanted to introduce you all these things. So I just jumped into system design directly. So you can learn Woop's concept and solid principles too. Okay. So we're having some set of rules. So this particular low-level design focuses on the internal implementation of the system. So what do you mean by internal implementation? While you're writing the code, you'll just keep some rules. No, this particular object should only be created once, or this particular object should only communicate with these classes. Only these classes should contain these methods. These classes should contain these methods. These are all internal implementation that you're focusing comes under low-level design. So this is where design patterns are used. So what do you mean by design patterns? So these are reusable solutions. It's like a kind of template blueprint of the thing of the way we code. So design patterns are reusable solutions to common problems in object-oriented design. They provide templates for writing maintainable and scalable code. So these design patterns provide a template for us. Creation. There are three major categories in design patterns, which are creational, structural, and behavioral. So and also we'll be having different design patterns in creational, different patterns in structural, different patterns in behavioral. So I guess there will be around 10 to 12, I guess, but I'm not going that deep into that. So I can give one design pattern. Let's discuss about single design pattern today, which comes under creational design pattern. Okay, let's not just divert into that other topics. So I'll just make it very simple for you. We have finished about the Docker introduction. So Docker is, simply we'll just pack entire application and send it to the Docker to run onto my systems. That's about the Docker. And coming to software design, while writing millions lines of code, we just need to follow some set of principles. That's where system design or software design is introduced. For the software design, we have HLD and LLD. HLD completely focuses on the architecture of the entire system. So what are the tech stack we need to use? How do we scale and all the things? And LLD, which focuses on the internal implementation of the system. So how do objects interact? How do we avoid code duplication? How do we make code flexible and all? So we are talking about the design patterns in low-level design. So design patterns are the templates. So design patterns are the templates. They provide templates for writing maintainable and scalable code. And there are three categories in the design patterns, which are creational, structural, and behavior. So creational design pattern mainly focus on the creating the objects. So how do we create the objects? So what are the rules we set for creating an objects? So these all things will be used in creational design pattern. For the structural design pattern, how do we connect objects? So it focuses on the connecting the objects. And for the behavioral structural design pattern, it it talks about the communication between the objects. So how do objects communicate with each other? How do objects communicate with the classes, methods, and all? So these are the three categories of design patterns. And as I said, if any, there is any final year, third year. So as you focus on high package jobs, I bet You can learn just singleton and factory design pattern. You can just learn two patterns in creational design pattern, and you can go with 100% confidence in interview, because for a fresher, interviewer won't ask more than that. So we can just learn two design patterns in the creational design pattern. So let's just dive into that singleton pattern and all. So what is singleton design pattern? Okay. So for the singleton design pattern, that restricts a class to have only one instance. So it's in the definition, it's in the name as well. So what is singleton? Only one single, only one. So there should be only one instance for a class throughout the application lifetime. Let's say you write million lines of code, we don't care. But when you're designing it in a singleton design pattern, you just need to have only one instance, one object for the class. We just need to have only one object for the class. So why do we need that one object? Is it, is it flexible to do like that? Yes, it is flexible. Let's say we'll be having different number of classes and all. We have only one database, right? So let's say you're coding in Java. What if you create, database connections multiple times? For the database connection object, you're writing it every time. So whenever you want to insert something into the database, you're just creating an object of that string, database connection string, and you're, calling that database connection. So you're connecting it multiple times. We just need one connection. We just need one time connection for the database, and we'll just add into the database whenever we require. But what are you doing is you're creating multiple objects for the database. Do you think we need 500 connections for a single database? For the database connection, no, right? We just need only one database. So for that, we just need only one object. So what is there in that? So that's where singleton design pattern helps us. Now only one object of the class. So singleton is a creational design pattern that restricts a class to have only one instance. So you can take that example, the database connection. We just need only one database. So I'll not create multiple database connections whenever I need to put something into my database. I'll just use the same object and I'll just call a method insert, or I'll just call a method retrieve and all. So I'll do that. So why should I create multiple times and waste the system resources, CPU and all? I won't do that, right? Even if you does in software industry, they'll just give you a pink slip and they will ask you to leave the company. So we don't need that. So that's where singleton design pattern comes into the picture. So throughout the application lifetime, you just need only one object and provides a global point of access to that instance. So wherever you use it, wherever you need to use it, that particular object only helps us. So the two key points for that singleton design pattern are only one object of the class and everyone accesses the same object. So in simple terms, when someone asks you about the singleton design pattern, you just say only one object for one class, only one object of the class. Okay, nothing. You need not to elaborate. Also, in simple terms, we need only one object for the one class. So that's it. And why do we need that? As I said, for the database connection. So and also we'll just talk in some memory terms also. So for creation of object, let's say in Java, we'll be creating. How do we create an object? Let's say class name. Let's say my class name is money. So I'll just create money ob, which is my object name. Money ob equal to new. New is my keyword. New money. So people who are aware of Java or C++, they know how to create objects, right? So there will be a keyword, right? New, which is used in object. So we'll be having two different types of memories in our system, which is heap memory and stack memory. So stack memory primarily stores all the primitive data types, integer and all things. And this particular heap memory stores all the non-primitive data types. So whenever you create an object is comes under non-primitive data types. So that whenever you use a new keyword, that particular object is stored into the heap memory. So when you create object multiple times, so new, that multiple news create multiple objects and it stores into the heap memory. See how much memory we are wasting for creating one object. Only one object that requires multiple times, we are creating multiple objects there. So which is wasting my memory space and overloading kind of thing. And also, as I told you, the example of database connection, and also it's very difficult to manage. It's difficult to for the people who are for the upcoming people who need to work on your project, it will be very difficult to use that many objects for them. They don't know which object is used for which method. Let's say if you have created one object and you have used for it to call the, connect the database. Let's say you have created another object and you have used to call, you have created the same object, but you used to call other method. So how does someone comes from another company, another project, or reads your code and identify that you have used this to this? He can't, right? Because even if he can't do it from the million lines of code. So there will be certainly difficulties in that time. So that's why singleton pattern helps. So as I said, a very simple term, singleton. Singleton. If anyone asks you about the singleton, you just say one instance for class. So how do we, I'm just giving for the people. I'm just giving a simple introduction to the coding as well in singleton point of view. So how do we create singleton? Singleton will have three characteristics. It will have a private constructor. It will have a private static method too, static instance. So static variable. It will have a public static method. So if you can see my screen, I'll just I'll just show you. No singleton code. This is my no singleton code. And for the people who are not aware of Java, I'll just explain this code also. No, basically we are having a class name no singleton. So in that class we'll be having a method. So you know what is meant by method, right? So a method is like a function. So this particular method printing something called singleton constructor called. So I'll just have this method, and I'll have my main method from where my code starts. In this main method, we are creating two new objects. So let's say s1, s2. So we are creating objects of same class. So these two objects will be stored in my heap. Do you think s1 double equals s2 gives true? No, it will just give me false, because you know since this new keyword is used, it will create two new different objects which is not required. So this is the example of no singleton, but we don't want that. We just need singleton code. So how do we do that? So let's recall the use cases of singleton. uh, what did we say for the singleton? We just need only one object. So we just need to prevent users from creating multiple objects, right? So what I does is I'll just create only one object in my global level, and I'll just put static method there. So what static does is it can be only called with a class name. You can't call with object. So even if you try to create an object, it won't allow you. So I'll just create a static object here. So private static, and also I'll just use private method because this object is only for this class. So I don't want any other object calling from this, other class object calling this class. So I'll just put private here. So only private methods can be called only in itself classes. So private static simple singleton instance. So this is an object here. Initially it's a null object I have created. So I have a constructor here, system.singleton constructor called, and also have a and also we just seen here we must have a private constructor. So let me give a brief about the constructor too. In Java or any other coding language, also in JavaScript as anyway, constructor is something like it will have a same class name, but what does constructor tells is it starts the class. So whenever you create an object, the first method that is called is constructor. So let's say we are creating a new object here, s1 equal to new no singleton. So this particular object calls this method, this implicitly. We need not to write s1 dot get instance, s1 dot call this method. No, we will not do that. So constructor means whenever we create an object, it just executes that. Even if we don't mention constructors, so Java will provide default constructors. So whenever you create an object, that particular constructor runs. So okay, so For creating a singleton design pattern, I just need to have one private constructor, and I have already told you why private is used, because it prevents the other objects, other objects of other classes to call these classes. So objects can be only called from this class itself. So I'll just use private constructor, and we have made private static object. So how do we call them in other method? We can't call, right? So I'll just have a public static method, and also so I'll just have a public method. So this can be called from anywhere, and also I'm using static here because I don't want this get instance method to be called in other packages or other classes or other methods actually, because we'll only create it one time, we'll only use it for one time. So what I'm doing was, so initially I have initialized the object to the null, and I made a private constructor, and I've used a public method. This particular public method, what does it do? So it just simply, if there is no any object is initialized, so it will initialize my object if my instance is null. So what is instance? Instance is an object. If my instance is null, so it will create a new object here. You can see here, we are only creating new. So did we use new anywhere here? We are only using it one time. See how this pattern changed. Instead of using new multiple times, this particular code only uses only one time new. So this is called singleton. For even we have declared the object by we didn't initialize it with a new. If we initialize it with new, some that means we have created an object. So what are we doing? Only my instance. If my instance is null, that's where we are creating an object new. If my instance is not null, so whenever a person calls an object, you say no, you stop it there. You don't create a new object. We have already an object. I'll just return that object to you. Okay. I'll just this particular method tells. So okay, even if you don't understand this code, it's fine. You can leave it, but you can just have an theoretical part. That's more than enough, I say, because I feel you can learn it furtherly, because we can't dive deep into these sessions in this particular moment. Okay, so simply let's say we will just this particular get instance. If there is no object, I'll just create an object. If there is an object that is already initialized, I'll just return that object. Since it is a singleton pattern, I'm not allowing you to create multiple objects. So that's the entire idea of this project. So let's dive into this main. So initially my instance is null, my object is null, there is no object. So I just wanted to create an object. So S1, instead of creating new singleton, what I does, I just call my get instance method. So I just call my get instance method. And also, how do we call methods? We'll call it with objects, right? So we'll just need an object, and with that object, we'll call the methods. But for creating an object, so what do we do? There is no object. We are calling a method for creating an object. So how do we do without objects? So that's where static comes from. Since we have used static, we can call this method directly with the class name. So the class name is simple singleton. So simple singleton dot get instance. So this particular static method is called. So this particular static method is called. So initially my object is null. So what does it do? Oh, okay, your instance is null. So I'm initializing a new object. So I have my new object now. So this particular S1 created a new object for me. So in my heap memory, I'm storing that S1. So okay, I'm storing that S1. And again, you're creating S2. You wanted to create another object, and again so since we have a restriction called we can't use new in the main, so you just call one more time get instance method. But what happened? Since we have already my instance is initialized with one object, so your instance is not null, so my condition fails here. So what does it do? It directly returns the same instance. Even if you wanted to call then another object, it gives you the same instance. So there is no new method here. So in my heap memory, there will be only one object with two reference points, which is S1 and S2. Let's say we have only one object with two pointers to it, S1 and S2. But what happens in this no singleton case? We have S1 as an object and S2 as an object. So for this object reference pointer is S1, for this object reference pointer is S2. You don't want that, because if you call this, let's say you're initializing, you're making a connection in the database here. You have created a new object here. So this calls the constructor. A database string is connected. Database connection is created, and again you are calling a new object here, and here also a database connection is created. We don't want that. Why do we need new two database connections? So we don't want that. So what does it do here? In my simple singleton, I'll just write a code to connect to my database. I'll just write it here, and then I'll call an object. Okay, so I'll call an object. So since my object is null, it gets created an object. So whenever this new is used, so in my heap memory, it gets an object. So whenever an object is called, so that constructor is called. Whenever an object is created, that constructor is called. In my constructor, I have a database connection now. So in my heap memory, I have only one object. That object made my database connection successful. And also another person tried to create S2 object for some other use case. So what does it do? In my heap memory, it only keeps this object. And it just gives a reference to this object. So S1 is used for some other case. So you point out the same object and take a reference pointer as S2, and you can use it to some other method. So this S1 and S2 is pointing out to same object, right? So when we print S1 equal to S2, definitely we'll get true. So these 2 points are different. Yeah, they are demonstrating, they're pointing out to the same object. So they are equal. And these are two different objects, so they are not equal. So that's a simple singleton class. And it's okay even if you didn't understand the code, it's completely fine, because you need not to understand this. And also this is in entirely Java. I choose Java. We can have C++, Node.js and all. So this is how singleton works. I guess you're clear with these things. Okay, even if you have a lot of confusion, that's okay. You can keep the confusion. You can keep the confusion, and right after the session, you try to research on your confusion. Why is the confusion created in your mind? So what are these so-called software developers do to clear these confusions and all? So you can research about that. So let's just recall what we have discussed. So we are just discussed about the Docker, and we just saw problems, how software developers think, and we just compared how a friend with only DSA, a friend with all these concepts, system design concepts, can work. And we have just seen the differences between the HLD and LLD, which focus on architecture, which focus on internal implementation. And from LLD, we have just came to design patterns, how our code is designed internally, so that our use case is satisfied. So we'll be having three different categories of design patterns: creational, structural, and behavioral. So we are just saying a one design pattern in creational design pattern, which is singleton design pattern. So singleton design pattern, simply one class, one object for one class. So why do we need singleton pattern? So every time we create an object, that new keyword creates an multiple objects, and that multiple object creates constructor multiple times, and we are doing it unnecessary times. So it becomes overload, which we don't want. So we just use we just want to save our heap memory, we just want to save our time, we just want to make our code readable. So we just implement singleton. So how does my singleton works? It works on the three characteristics. So definitely I should have a private constructor, because it can't be accessed from other methods and other classes. And then I'll be having one private static instance, private static object. So that's the only object. Whenever an user creates multiple times, that's the only object that is returned to all the users. And one public method. So have you ever wondered why public method is used? Because if you keep this also private, how can you create an object? So you're creating it from another method. So definitely, sometimes you may create from the other class also. But definitely, there should be a method which is accessible. So that's why we are using this get instance method as public. So these are the three characteristics of singleton class, we say. Um, okay, that's about singleton. So even if you didn't understand this code, I'll just give a real-time example, and I'll just not explain all this code. These kind of codes are not useful, I say. So let's say we are building a college management system. So our college approached me, to build a management system. Uh, the management system currently they are using, it got outdated or something. So they just reached to me. So they asked me to create a college management system. So what are the requirements? What are the modules we'll be having in college management systems? We'll have admission departments. We just need to track attendance. We'll be having library. We just need to administrate fees, hostel, faculty, and all. So let's say I have picked these things for the college management systems: admissions, attendance, library fees, and all. Tell me one thing: you go to admission department and ask the college name. Or let's say I'm from Trinity College. So I'll go to my admission department. I'll ask the college name. So what does that admissioner who is that person sitting in the department, what does he say? SNIC or Trinity College. Okay, I'll just go to my HOD attendance department who manages the attendance. So my coordinator, I'll just ask him, what is my college name? He says Srinidhi again. So I'll go to library and I'll ask the librarian, what is my college name? Again, he says Srinidhi. So I'll go to admin block and I just wanted to pay fee. And again I asked, what is the college name? Again, he says Srinidhi. So I went to the college hostel. I asked, what is this? What is this hostel? So which college, which for what college this hostel belongs to? Again, they say Srinidhi, and I'll just ask faculty, what college are you working on? What are you working in? And which college are you working in? Again, they say Srinidhi. And also, in the same question, in the same way, I'll just go to every department and I'll ask the principal name. Everyone says the same name because there is only one principal for the entire college, right? There's only one name for the entire college, right? We'll not be having different college names for different departments, right? So, so while you're writing code for the admissions attendance library, do you really think you need to mention every time, for the admission department's college name, principal name, for the attendance department, college name, principal name, for the library department, college name, principal name? Do you think it is required? No, right? We can have them globally, you can have them displayed somewhere out of my college, from my old, global access. It can be globally accessed. So when I go to my admission, you can just see that board and tell. So there it is. There is my it's my college. So I can go to my attendance department. Then there he shows, that's my college. That's my principal name. So I'll just make that just singleton work. So whenever an object is created for that my college and principal, so there will be a board displayed in my college with the college name and principal name. So whichever department you go, they'll just show that board to you. So again, you need not to ask. So let's say if you want that, let's say you went to the admission department and you joined as a officer there, and you wanted to do the college name, you just see that board, which is globally accessed there, like globally available in my college. So in the same way, that's the same pattern I have implemented there here. So I just made college object as private because I don't want multiple times, creating college name and principal name object. So I just created my college object. I just created my college object as private static because it will be only created once. And also there is a public method. So if my instance is null, I'll just create a new college. So this new college, so the constructor is called. So whenever a new object is created, this constructor sets my college name and principal name. So if someone again asks you the same question, you just need not to create a new object there. You just say, so the board is displayed there. So the object is already created. You can access from that object. So why do you need to create an object and know everything from scratch? We don't do that. So in my admission module, I'll just create an object. How do we create an object? Not with the new again. So I'll just call that get instance method. If there is no object, I'll get that college name. So in my admission module, with only one object, I have access to an admission module, in my library module, in my attendance module. So I think you got a clarity about the use case of this singleton, right? Uh, do you have any doubts in this? Okay, I guess there are no doubts. Okay, fine. So what are the advantages and disadvantages? So advantages, let's say, while we create multiple times, so we don't want that. So we don't want to waste our heap memory. So it just saves memory and gives global access to all my methods. So it keeps my data consistent and better performance and resource sharing and all. And disadvantages, so global state means hidden dependencies across the modules. We'll be having some. We don't need these all disadvantages. Let me tell you only single disadvantages. How many of you know about the threads? A thread is a part of the process. It shares the same memory. And how do I explain the thread? Okay. Um, Fine. So thread is the smallest unit of execution. Let's say you're playing on YouTube. What does YouTube say? It loads the comments for you. There will be notifications coming, and there will be recommendations coming in the right side. So everything at a time, simultaneously. So for each process, that's called a thread. One thread is loading comments, one thread is showing recommendations, one thread is showing, that notifications and all. So that's a thread. So thread is the smallest unit of execution. Let's say initially, let's say how does this singleton fail? What is the disadvantage of singleton? Initially, my object is null. So there are two threads. Let's say YouTube threads only. There are two threads. One is for the recommendation. One is for the comments. So initially, they both try to access that instance method. So since the instance is null, they both created an object. So how does this possible? Is it possible in singleton? We are not allowed to do that, right? So when this thread comes into the picture, the singleton fails. So how do we overcome that? So we'll have some methods. Mainly three methods are there: synchronized eager initialization and double check loading. So we don't want that two objects created because we don't want two DB connections. So similarly, so we just need to solve that problem. So what do? We'll just use these methods. The first method is synchronized method. So what does synchronous method do? So it's a part of operating systems concept. So what does it synchronized method do? This particular synchronized method, what does it do is, so when a thread comes, so it will tell the other thread, one thread is already using this particular object. You please wait for some time. So this synchronized manages these threads, multiple threads. So it only allows only one thread to access the resources. So it just allows thread A to access the resource and create an object, and it'll just ask thread B to wait. So that's the one way we can, you know, overcome this problem. And what is the another way? Eager initialization. So instead of creating it null, uh, you create it in early only. So whenever you're declaring an object, you create it there only, there itself. So when someone calls to get instance method, you just return that object. So create a object. So instead of waiting, instead of from changing null to new object, you just create a new object, then you declare only. So no issues. So why does through two threads checks nulls and create objects? So they won't break, right? So they just use that same object which is already created. So no issues. So eager initialization, one of the method. The best method for solving this thread problem was double check loading. So double check loading is the same as synchronization only. So what does it do? So while creating object only, just ask you to synchronize the threads. If there is any process, any method is being called by that object, so it prevents other objects, other methods to call this the same object. So you are using synchronize while creating only singleton class. So I don't want to explain deep into these all methods because these are all advanced topics. We just don't need them. You can just tell, there will be three methods to overcome this thread problem. There will be synchronized eager initialization and double check locking. So we'll just check two times whether to allow that particular thread to use the resources or not. So that's what double check locking is. So we can just tell these three topics. So simply, singleton is a creational design pattern used in low-level design to ensure that a class has only one instance and provides a global access point to it. So it is useful for shared resources like configuration managers, application settings, cache managers, loggers, and printer managers. So this is a summary what I have told. You can just like a snap of it or something. So if you want, I can share my PPT as well. And I hope you got a clarity about these things, right? Uh, as a student, we don't focus on all these things. We just focus on we'll just open ChatGPT, we'll just open Claude, and we'll just ask it the code, entire code, and we'll just do something with our knowledge. We'll just modify it. So as a student, we only does this, but as you grow, as you get into the software industry, but you will be doing these all things. You just need to know all these principles. There will be a training given, but if you get to know all these things before only, so definitely it will help you in landing good package. So so this is a simple introduction about system design. I just wanted to share it with you all. So I hope this session is good. It went well. Yeah, Saumit, are you there? Hello. Some. So now today we know what is Docker, what is system design, and all. So when someone speaks about system design, you can just feel that okay, system design is for creating an applications in a particular manner. So you can do that. You can tell them. So whenever someone asks you about the system design, you can just tell these all things. And just wanted to give it a task, so you can explore entire system design. What is system design and all things. I have given you the all the introduction about that. So now onwards, you can explore the other patterns also. I just wanted you to explore factory design pattern. So I've explained you about the singleton design pattern. I just wanted you guys to explore factory design pattern. So it will be similar to singleton design pattern, but the use case is different. So you can open YouTube and type factory design pattern. Yeah, and you can explore these things. And believe me, these two things are more than enough for a getting into good package. For the fresher, these two patterns are very basic things. That's more than enough. And thank you guys for attending my session, and I hope it went well. And you can ask in the comment section if you have any doubts. If you want to connect with me, you can connect with me. I can share my LinkedIn as well. Thank you guys. Samit, you can end the session. You can give a close note.